Hi guys, in this video I want to show you the workflows and tools that I use to train machine learning models in the real world. What's the problem? Training machine learning models and saving them locally in your laptop has zero business value, no matter how accurate these models are. Because the whole point of training a machine learning model is to later deploy it to a production environment where it can generate predictions that can be used by downstream services or human operators to improve business metrics. Now, to deploy a model, you need to somehow bridge the gap between the development environment or the training environment where you train your model and the production environment where this model is later deployed and used to generate predictions. But the question is, how do you bridge that gap? And here's the solution. The easiest way to transition your models from training to production is to use a machine learning platform, which includes two services: an experiment tracker, where you log all the metadata of your training runs that you later need to inspect the model and to deploy it. And the second is the model registry, which is the central repository where you push your model artifacts. This is a place where you save your models, where you can read your models, and where you can version your models. And these two services are the bridge between your training environment and your production environment where you do inference. Let me walk you through an example. Come with me.
Yeah, it's Pau, the same person who was done. Yeah, the same guy. So let me walk you through the steps to write a professional training script and log everything you need to the experiment tracker and to the model registry. And for that, we're going to use Comet ML. Let me show you the code. Bam. So here's the code. This is what we built last week, building a real-time ML system together, where we built and deployed an end-to-end machine learning real-time system to predict crypto prices every 5 minutes. And here's the training script. So the first thing that I want you to pay attention to is we don't use notebooks, okay? So you encapsulate all your training script into a function where you make all the input parameters as parameters to this function. So it's fully transparent. What are the parameters you need to pass to this training run? And then inside, we follow the typical steps, which is we first fetch the data that we need for training, which doesn't come from a CSV file, but from the feature store. Once we have that data, we split it, and we do that at the very beginning to avoid leakage between the training set and the testing set. Then we prepare the data. In this case, we are following a time series modeling approach, so we need to interpolate missing slots. Then we do some feature engineering, and then we compute basically the performance of a baseline model, which we need to understand what's basically the metric we should improve. And then later on, we try a machine learning model. So this is everything that's implemented in the train function. Now, typically, when you train a model, you will need to rerun this function hundreds, if not thousands of times. Every time changing an input parameter, changing something in the code, adding something new. So this is a piece of code which you are constantly iterating on. So it's really important that you track the results of every training run. This is something that you do through an experiment tracker. In this case, I'm using Comet ML. Comet ML is the platform, the experiment tracker that I use in normal projects because it's serverless. So I didn't care about running any infrastructure. It has great features like custom visualizations and also model registry webhooks that really help us later on to deploy models easily. And also it's free for individuals like you and me. So first of all, if you have an account in Comet, it's very easy. You just go, let me show it to you. You go to Comet. Here, I already have an account. So if you haven't, you just go to comet.com and sign up, and you create a project for free. Here I have several projects because this is what I'm using. And this is the one that we use in the first cohort of my course. This is the bunch of experiments. So here's the panel with experiments. So we have it ready. Now, in order to log runs from your Python script, you will need an API key. So here on the upper right corner, API key, boom, you can copy yours. This is obviously a secret that you should not copy paste directly in your source code. Instead, you should set it as an environment variable that you source before running your Python script. This is something that I already did. So this is my training script. Now, how do you start logging runs? The first thing you need to do is, obviously, if you haven't, from the terminal, you need to install the Comet ML SDK. In my case, I should run poetry add Comet ML. If you don't use Poetry, you can simply run pip install Comet ML. Once you've done that, you have Comet ML inside your virtual environment. And now we start basically the training run. So the first thing, at the very beginning of the training run, you create a so-called experiment. So this is the basic object that you use to log all the metadata that we are going to need. Now, the first thing that you obviously need to log are all the input parameters that you pass through your training run. So in this case, a couple of parameters regarding feature views. This basically tells the training script from where should I generate the training data. And then some other parameters that basically specify the window, the horizon in which I'm running the prediction, and some other parameters like the product ID. This is the asset for which I want to make the prediction, and so on. So these are basically parameters that every training script needs. And as I said, the first step is to fetch the data from the feature store. Again, no CSV files. The first thing that you need to log after getting this data is what is called a dataset hash. So basically, you don't want to log the entire dataset to Comet because this is going to be colossal, but instead you generate a hash. This is a unique identifier that Comet ML generates from the data, which helps you track changes in the input data to your script. So if we train again this model after 3 days, and we get a different hash, it means that the training data that we're using is different. So we also should expect the results to be different. So this is a very useful thing to log, the dataset hash, so you can understand if the dataset you're using between runs is the same or not. After that, we split the data, and something that you obviously need to log is the amount of rows you're going to have in your training set and in your test set. This is also an important metric you want to basically check. Then it comes the step 3, the interpolation. So data pre-processing before model training. And here's something that, for example, I'm interested in this case is to plot the number of interpolated rows. Like if I had to interpolate a lot of rows, maybe this is a warning signal. Maybe this tells me that I should validate my data before entering the training script because I have too many missing values. So this is also an important thing that I would log in this case. And then in our case, we don't have the target metric already defined in the data, so we need to create it. So here I create the target, and here I plot something which is quite useful, which is the histogram, the distribution of my target metric. In this case, we're predicting price changes in the next 5 minutes. So this is a histogram which is centered around 0, but it's interesting to see the distribution. So this is a plot that you can also log to Comet ML. So step 5, we build a baseline model. In this case, it's a very simple model that predicts that the price change in the next 5 minutes is going to be 0. And then finally, before jumping into the model, we log this baseline metric. This is important to understand if our training run actually created a model that is better than the baseline. If it's not better than the baseline, basically, we didn't really make any impact. So after logging the baseline model error metric, we do some feature engineering. This is a typical step that you add to your training script to increase the signal that you provide to your machine learning model. So feature engineering is always very domain specific, but it's something that you need to spend time on to improve the overall performance of your model. Then finally, this is the list of features that are sent to the model. And here's the part where we feed the model. In this case, I'm using a lasso model. This is a linear regressor with some regularization to avoid overfitting, which is more powerful than just the simple regression, but it's also not too flexible. And in this case, I use it because I'm afraid I'm going to overfit if I use a more complex model because I don't have so much signal in the input features. But again, this is something that you need to experiment. So you only know that after rerunning this script thousands of times. And then finally, we evaluate the performance of the model. So we log this metric. Now, finally, the key step is that the model artifact that we've generated, if we save it locally to disk and that's it, basically we haven't made any impact because the whole point of training a model is to put it somewhere where it can be later deployed. And this somewhere is the model registry. So if you go back to Comet, here under your project, there's the model registry. So here is where you log all your models. For example, this is the model that we are training here. And for each model, you have different versions. So as you push a model, Comet ML automatically generates a new model version. And then very important, there is the status, which is you decide what's this model suitable for. Is it just a model for development? Is it a model for staging? Or is a model ready for production? This is very important. So this is the last step of our training script that we do here. So we log the model artifact and we check. If the model is better than the baseline, we push it to the registry, which we do right here. So enough talking, let me run this thing. So I have a make file that basically help me run this script with just make train. And I'm going to check the Comet ML dashboard right here. And you will see that there's an experiment running. This is precisely the training run that I just started. So if you go back to the console, now it's reading data from my feature store, from HubSworks, and it's running everything. So here's the run. So I can go back to my Comet ML dashboard. And now the experiment should be completed. So this is the list of experiments. For example, you can compare metrics among experiments. In this case, I'm making sure that I have the same number of rows and test data, which they do have. Now you can also dig deeper into each experiment. So I'm going to click on the experiment that I just ran, and I'm going to check what did I log. So these are all the metrics that I logged, basically dimensions of my data. I also log some other hyperparameters, for example, the dataset hash, as I said, which is very useful, the feature view name and version that I'm using to generate training data, the features that I'm using, and so on. There's also graphics. So I also log the histogram. So this is very useful. I can also see the distribution of the target metric that we are predicting. So, and also something that is very nice of Comet is that it automatically logs a lot of stuff for you that you don't need to care about. More importantly, the source code. So if you click on code, you can see the exact source code that was used in that training run. And that is really useful when you want to compare two different training runs. So let me do that. Let me go back and let me compare this version with maybe this previous one. And then I click on compare. So if you click on compare, you can establish a one-on-one comparison between metrics, parameters, and all the relevant factors. For example, the source code. So for example, here I can see there's a slight difference in the number of rows in the training set between the two runs. Now regarding metrics, exactly, I can see here slight differences because the data is slightly different, and now I understand why. And also regarding code, are there any changes? So let me check here the unified difference. So yes, there's a split diff, exactly. So here, for example, there's a difference in the way I plot the histogram, the number of bins, and basically that's it. That's your file. So no really relevant differences in the source code, but differences in the training data. And this is the whole point of using experiment trackers, to understand basically what's happening between experiments, and also really important to log metrics that you later use to deploy the model. In this case, for example, feature view name and version are things that I need when I deploy the model, because the data that we are going to fetch from the feature store when we run inference needs to be generated in the same way as the data that I use right now to train the model. And these are the two parameters that precisely help me do that. Now, finally, if you go to the model registry, you're going to see basically the latest version of the model. So in this case, if you can see, these models are not regenerated right now. And this is because my model didn't pass the model validation. So here, the last step of our model is to compare in the training run. If the test metric of my new model is better than the baseline, then push it. Otherwise, there's no pushing. So this is why I don't see the model. So that's it, guys. I hope that you learn how to use a machine learning platform like Comet to experiment faster and better.